And we're live.
Is that your dorm room?
No, this is my room at my house, actually.
Nice.
Oh, nice. Great. Well, it doesn't look like we have any viewers yet, but we will get started, and we'll just give everyone a recap of the different aspects that we're working on for the project. So presenting today is myself, Katie, Samantha, and
I'm just the secretary.
and Patrick. Patrick is back in Iowa now.
Aww, so sad.
And we miss him, but he's still been contributing a ton to the project.
This is true.
Okay, I'm going to share the presentation with the team now, with the viewers. Okay, so live from Re3D, Austin Mission Control. As we figured this out.
And Iowa.
And Iowa.
So, can you see it, Patrick?
I see black right now.
Oh no.
Aww.
Huh.
Sometimes it takes a minute.
Okay.
I
Some kind of comment.
mission control now again.
You can see it?
Yay!
Can you see it?
Compliments of Chris
Yeah, I see mission control.
at Gertie33, who has a Wikipedia profile.
Oh, I love that.
Check him out.
Patrick, can you see that?
No, I can't.
Oh, okay. I don't think that's going to work.
Dang it, dang it.
Well, we're figuring this out, so thanks for bearing through. Yeah, so hopefully by now all the backers have received their pledge level.
Including Sean
backer.
Fitzpatrick, who bared with like every export compliance sender issue we could have encountered.
And
minus Nate Stewart. We would love your address.
Right.
Yeah.
They're open source hardware angels. That's what we want to think of you guys as in this project. This is what is keeping the project afloat and what is keeping us thinking about how people want to modify their printer.
We wouldn't have been here without you.
So last week we had to reschedule our Hangout session because we were requested at a Python meetup. And at this meetup, it was great because we had the opportunity to really learn more about the software that we were developing and what challenges we need to think about, all the considerations that have to come into play when you're designing software. We have a really talented software developer right now in Australia who's been doing some great work on the framework and the back end. He is a maker, and so he's been taking it in strides, but for us who are not developers on the team, we are really enjoying understanding more about what goes into those decision-making processes and all the considerations that he's doing. So at the meetup, one of the biggest things that we took away was that we're going to need to choose an open source license. And it's a pretty important decision for Re3D overall, and we wanted to bring it up to the team because we feel that this will set the tone for the rest of our decisions if we ever decide to execute other open source softwares, if we decide to create software frameworks off of what we're developing for your Kickstarter campaign. So we will publish to the team what we decide to do, but we are considering as much as we can right now. And we're learning that there are two schools of thought around open source. One is that everything should be permissive and people should be able to build their own programs and start their own businesses off of your software. And the other school of thought is if you're developing software, it should always remain open source. And that's called code left. So we will be evaluating this, and we will try to take as many concerns as possible into our decision base. But again, the Google community is a place where we want to have these discussions. So we really encourage that. We're in our next phase of wireframing, and the interface has been thought of as being a area that can alleviate a lot of the woes of printing, and so we've been looking at it as a quick start process and being able to really follow instructions quite easily from an interface and manage your projects into folders and quickly get a snapshot view of what is going on in your files from the metadata standpoint. And so we're also taking a lot of that into consideration as we develop all of that content. It's a very collaborative process between Mike Battaglia, Levi Lala, James Stewart, and myself, and Matthew as the engineer. And most recently, Patrick Heather has been involved as well, coming from the materials angle, because he's been doing a lot of materials research, and so he's given us a lot of considerations, as everyone else has on the team, about what type of functionality really needs to be in the feature set on our software. So we're developing an API, and what that means is basically it's features that are available from Open Gigabot that the hardware understands, the firmware understands, and the software understands. So this is the list that we currently are at, and we're continuing to build it in a collaborative Google Doc. And we'll share that with the rest of the team and with the backers once we come to a more finalized standpoint on it. As far as all of the interface wireframing goes and how we're testing that out, we have 2 different mock-up sites that we're evaluating, and they come from 2 different perspectives. One is more of a front-end UI experience, and one is more of a back-end functionality perspective. We started the project off with the goal to create a touchscreen interface and a remote application and web application. So now we're trying to merge the 2 as much as possible, so that they're a seamless, similar experience. And really what we're focusing on first and foremost is what you are able to do on your machine. We've got to take into consideration the size of the screen, the resolution, the capacitive touch on the phone versus the resistive touch on the screen. And we're doing all the testing and prototyping from different perspectives across the entire team. So here I'll let Patrick step in because this is really his domain and his expertise. But what we are building right now is the next assembly of Open Gigabot. And we're taking apart the prototype constructed frame, which is pictured on the right, and on the left is the prototype that Patrick had put together. Picture on the bottom is the filament spool roller folder that we showed you last time that we got together. So Patrick, I'll let you take it from here.
Yeah. Oh, the picture on the left.
Oh, cutting out a little bit. Sorry.
Let's see if it works a little better here.
Yeah, that's good.
Does it sound better now?
Yes. Yep.
All right, cool. So here we have pictured the assembly so far in exploded view to kind of show all the different components. You can kind of see we have paneling on all the sides now, which includes, I like this one better. Yeah. You can see the aluminum side plates. We had side plates and some aluminum corner gussets on the original Gigabot, but on this one we're using straight side plates for most of the design and getting rid of the aluminum triangular corner plates. And then all the yellow is what will become a plastic paneling, either acrylic or polycarbonate paneling. They'll be transparent. And here you can see the hood design as it's coming along so far. And then fixed paneling on the sides. And then on the front, you see the two double doors. So those will be two doors you can open, and that will provide you access to getting your print, and that's what you'll be using most of the time to get to your print, unless you need to use the extruder, in which case you'd open up the hood. The other thing to note, on the bottom front, there is another panel, which is also a door. That'll be a drop-down door that drops open like a post office box door or whatever. And there'll be one on the front and the back, and that will allow you access to your filament that's on the filament spool rods that's currently being fed into your print, and also in the back section where you can store filament you're not using. One of the things we've been talking about as we've been going along is hinging. On this, well, actually, I'll save that for a later slide in case you have that, Katie. Do you have a slide specifically for the hinges?
Yes. Yep.
Yeah, okay. So here, there's a couple different options for how we can do the hinging. We can do like traditional style small hinges, or we could do a piano hinge, which is slightly over-engineered, but it would look very nice and it would be pretty sturdy. So we also were looking at, do we have a hinge on the inside where it's mostly hidden? There'd be a small gap to allow the panel line to open, but you would be able to see the nuts on the back side. That, or you have the hinge on the front facing outward, and you see the hinge in the head of the bolts, but not the nuts. So we kind of wanted to get some input from our backers what they think looks nice. Do you like the hinge on the hood that is on the inside, or you prefer the hinges on the door that are on the outside? Do you prefer piano versus regular? Any thoughts from either of our backers here?
I like the piano inside.
You like it on the inside?
Yeah.
No.
Okay. So you don't mind having the nuts poke through and see like those on the outside?
Oh, so the nuts will be seen?
The nuts will be seen.
Oh no, then sorry, outside piano hinge.
Yeah. Yeah.
Because that's just something that'll snag things.
Huh.
Yeah.
Hmm.
That could be a concern.
Mike.
What's that?
Yeah.
Oh, sorry, he was.
Oh.
She was thanking you.
Oh, okay.
Yeah, we were just kind of like talking about different ways we could do it. Some people thought it'd be best to hide it. It could, but the only way to completely hide it would be as if we attached it with some sort of adhesive or something. But we really like having fasteners there. It's much more solid.
Well, what you could do is on the piano hinge, you could actually put a flexible material over it.
Mm-hmm.
That
is true. It's possible.
That covers the hinge, but still is flexible. So would seeing the hinge itself be more unsightly than the flexible material in your mind? Well, I'm saying, well, you can have the hinge, but if someone really just doesn't like it, you could put a flexible material over it, so it's not obviously a hinge.
Mm-hmm. Mm-hmm. I see. Yeah, makes sense.
Mike, this is Samantha. Do you mind sharing why you think the piano hinge on the outside is better?
Well, because if you have the nuts facing outward, you also have the fasteners, the screws. It's just something you're going to catch on.
Why can't we have the...
If you flush with the hinge, it'll be less likely to snag?
Yeah, that's the only thing I'm really concerned about is the snagging.
Why can't we have the hinge on the inside countersink the screws from the outside with the nuts on the inside?
Hmm.
Yeah, that's one way we could do it. That's one way. So you still see the heads, but there would be no snagging. So that we could do it that way for sure. I was just thinking that seeing anything through the top, as in the head or the nut, might be unsightly to some people. But if you guys don't mind it and it's just a snagging feature, then yeah, we might go with the head on the top. Maybe countersunk or not. it would be easier dealing with 1/8 inch thick paneling, just to have a through hole, and not worry about the countersink. But
If
I
it's
could
only
look
1/8.
into that.
Well, even a panhead screw on, like I said, on the outside would be less of a snag than the nuts.
For sure, for sure.
Mhm.
All right, cool. Well, thanks for your guys' input then. It looks like we'll try to proceed with piano hinge on the inside with the head on the outside.
The only the only concern I have there is if you countersink that, those can get over tightened and crack the acrylic or whatever material you use. So you just have to be careful.
Yeah, and that's why I was a little concerned since it's 1/8. So if we see that's a problem, we could maybe test it out on a piece, but we will. Then we could just use regular button head cap screws like we use on most of the rest of our Gigabot, and those would work, and we wouldn't have to countersink.
Yeah.
If you're looking at a acrylic cover, I mean, you could just use a acrylic hinge that would be glued on, and then you'd eliminate the fasteners and the.
Yep.
That's one idea. I think some of us wanted to steer away from adhesives, just because it's kind of neater and almost, in most cases, I'd say more sturdy to have metal fasteners. But that's something we can investigate further if you guys feel strongly about that.
Well, it eliminates the. I mean, no matter what you do with fasteners, you have a bit of a stress point, right? Which is probably why my gut reaction is to go with the piano hinge as opposed to the two separate hinges to begin with.
Mm-hmm.
You know, it's just that you're not relying on just those 4 little holes through a 1/8 piece of plastic, right?
Yep.
But you know, an adhesive hinge, a hinge that's held in place with adhesive, you eliminate your stress points. So, and with acrylic, you know, it's a fairly standard way to assemble acrylic objects. So.
All right. All right.
And for that matter, I mean, I don't know if anybody's thought about that. I guess just looking at it, it looks like when you open the lid, it does sit on top of the Gigabot anyhow. But I mean, the other option you have with an acrylic hinge fairly easily is to have a hinge that you can, you know, open it part way and then slide it sideways and take the hood right off the machine too.
True. That's a very good point.
Hey, Sean, I'm the biologist in the group, and I'm just taking notes, but just a thought. Do you think that, like, if we went totally adhesive, we could use carpet tape, or would we have to be committed to an epoxy at that point?
It's been a while since I've done anything with adhesives with acrylic, but I mean there are acrylic adhesives that are clear, I guess is what I'm picturing.
Mm-hmm.
So you know, you basically wouldn't see the adhesive as opposed to, like, you know, carpet tape or whatever. Typically you
use that for the local
layer.
plate. That's my point of reference. Yeah.
Like I said, yeah, it's been seriously a couple decades since I glued anything together out of acrylic, but but you know, my memory it was that we had a clear acrylic adhesive glue that you know, even on clear, like, I mean, even on clear acrylic, you didn't really see it. It was water clear adhesive.
So it wasn't UV cured?
No.
Okay. And I'm sorry, I'm trying to take notes here for Katie, and I'm failing. So you said the advantage of doing that was so that you could also, the benefit was something with a hood?
Well, I'm kind of picturing 3 advantages. One would be you eliminate your stress points, and so you don't have fracturing around your bowl holes, and then you, from an appearance standpoint, you know, we've kind of had some talk about these fasteners potentially being snag points and also not necessarily being all that attractive. To me, a water clear adhesive with an acrylic hinge would be, quite attractive.
Okay.
And then the other one is that you should be able to get in an acrylic hinge. You should be able to get one that allows you to, like I said, open the hatch halfway and then slide it sideways so that you can remove it if you so desire.
Trying to picture that. Yeah, I may have to do a demo. Sorry.
I can try and sketch something up and email it to you guys too.
No, that's so cool. I really appreciate that input. It's very awesome. Mike, does that seem like something that's feasible from your perspective?
Yeah.
Would you like that better or worse than the piano hinge idea?
The only thing I think about is on acrylic hinges. I mean, piano hinges are pretty easy to come by. I'm just thinking about, cost and replacement sourcing. But I like it aesthetically, yes.
But
You got to remember, acrylic deteriorates, and so we're going to have a problem. I mean, anyway.
Nothing on your Gigabot ever breaks.
Oh no.
Just
not without some effort. I think I'm still the only one who had to replace the bed plate, right?
I was just about to say that. Says the guy that dumped battery acid on his Gigabot.
I didn't dump battery acid. I had a spill.
Overnight.
Yeah.
Let's hear that story sometime.
Yep.
On record.
Oh my gosh. How funny is that?
I can start saying things that'll cause you to have to bleep out everything.
Have you seen our new terms and conditions?
Oh, no.
If you pour battery acid on your Gigabot,
Oh.
you may need a replacement part.
Alrighty. So if you want to, I could talk a little bit more about a couple other things. If you want to go back a few slides, Katie, please.
Oh, sorry. One more question on that.
Yeah, go ahead.
With the view or the slide of the hood there, it looked like there was a gap between the hood and the main.
Yeah. And when you have the piano hinge on the inside, to have the hood open outwards, if there's no gap, then as it starts to open, there's interference between the panel.
Exactly, yeah.
So that is one aspect of the inside hinge, so you'd have that little gap. However, the only thing you'd be able to see through that would be the back side of the piano hinge, so it wouldn't be any gaps to see into the machine.
Perfect. Yep. That was basically my my question was just I'm assuming that the gap was only where the hinge was and not like all the way around kind of thing or whatever. So yeah.
True. Yep. And the hinge will cover the entire gap.
Yeah. Perfect.
Yep.
Okay.
Alrighty. Katie, could you go back one more slide, please? So here we're back to the exploded view. Oh, okay. And there are a couple things we're talking about. We're currently working on the electrical box, which we are hoping will have the touchscreen interface built into the front of the electrical box here. You can see that. And they have a mock-up size for it now, and we're still working out the details and the finalized size for it. But now we're trying to figure out where we want that. In the previous prototype, we had that touchscreen on the front of the paneling on the front face, but now we have large double doors that take up the whole thing. And we're thinking it might be nice to be a little bit higher and be out of the way of those doors so people can get their large prints. So one idea was to attach it to the top of the frame and just have it cut out in the hood so that it would be attached to the frame. You'd open up the hood and it would stay attached to the frame there, and either be straight out or angled, and that might work well. A couple concerns we've had thinking about the electrical box is if it's recessed into the bot, there will be some limitation of build volume in the Y direction. However, if it sticks out from the bot, we can prevent it from limiting build volume. They would have tons of space for the bridge rail to slide back and forth. But if it was sticking out, then it might have to be the case as if you take your Gigabot through a doorway that's more than 30 inches wide, you would have to remove your electrical box to get through that doorway. So we're debating and wondering what people think. Is it best just to have it inside a little bit and take off a little build volume, but keep that envelope doorway accessible, or let it stick out a little bit and then take it off when you go through doorways?
How difficult is it to take off?
That's the thing we're working through right now. Currently, there are quite a few wires and cables that go to the electrical box, but we're looking into a nice connector scheme. Hopefully, an ideal case would be we bundle all the cables up, and it all runs into a special custom connector, which would have all the ports on it, and then it would just plug into the receiving end, and there would just be like one attachment that you'd have to disconnect that would contain all of the cabling. We're still working with our guy who knows a lot about connectors with this, but that would be the ideal case.
Well, first of all, the use case for going through doors is probably, not necessarily rare, but right, I wouldn't design around, well, how often is that can happen, but if you did it where you got it extended and you got the cable bundle, if you fixed it where you could open the hood, fold it back, close the hood, then you don't really have to take it off. But if you could find a way to do something that was relatively simple there, and you'd solve both of them, you could leave your Y and kind of pivot it, close the hood. You might not be able to close the hood over it, I don't know, but something.
Yeah, or have it on like a little set of mini sliders or something, kind of like drawer sliders. You could just slide out and lock and slide in when you need to go through doors. Or that sounds like a great idea.
So we counted, and there are about 16 different wires that are coming out of the current configuration for the electronics box.
Right.
So if we can somehow couple them into two openings for wiring on the left and the right side of the machine, then hopefully the bundle could just be plugged in and plugged out. And then that way too, we've talked a lot about this with our customer support manager, Mike, and he would love if we could take the box off, and if it needed to be, if it needed some work done on it, then it could be sent into support and as a unit instead of having instead of having it as something that's permanently fixed to the machine.
Right.
It would allow more hackability.
I personally would think that both from an assembly standpoint and from a maintenance or repair standpoint, that you're dead on. That having that componentized so that you can remove that would be a huge bonus. Like I really don't think you want to do it hardwired in or with so that you have to.
Right. I replaced my electrical box.
Wires.
Yeah, I replaced the electrical box on my Gigabot, and yeah, it was an undertaking.
So
Yeah,
if there's any hope of doing that.
Well, we're definitely, right now we're just looking into the connectors, because that could also be a stress point. If the box is affixed and any movement or torque happens on the point of contact between the connectors, the box, and the machine, we want to make sure that that's secure. So if you have any suggestions on terminal box wiring from the box to the machine, we're all ears.
Yeah, I'll look into that. We do a lot of that in my company.
Okay. Oh, that's cool. Great.
Any quick thoughts on angled versus flat with the front? Keep in mind
tall,
that
I prefer angled.
it's going to be at about 52 inches off the ground. So for anyone who's about my height, I'm 6'3", or even like I'd say 5'10" or above, angled would be nice.
Yeah.
Mike is tall.
Everybody else feeling angled too, Sean?
It wouldn't be the challenge for that it might be for you guys, but it would be fine for me.
Okay.
Yeah, it's just a little slightly harder to design that way because
Well,
the diagonal will take up more space front to back. So if it did slide or pivot in and out, it would have to slide or pivot more.
we looked at anthropometric studies and ergonomics, and angled screens at about 50 to 60 degrees are the most comfortable for use. So that was something that we'd also benchmarked and researched around. So it seems like the research converges there. But Samantha had a note. Just she wanted to ask one other question about that configuration.
So just to be clear, can I ask, are you talking about essentially sliding that control panel up from where it is right in that picture right now, up onto the angled face? Or are you talking about something else?
The top right picture is the first prototype, and that is not what we're currently proposing.
Right.
We're proposing what you can see in the bottom two pictures where it's angled and on top, and that's the most updated and sounds like what people want.
So if we look at the top left picture, it's not angled there.
No.
Yes.
So what I'm asking is I'm assuming then that you're pushing it up onto the angled face, so it actually would be a little higher than it is in that top left picture.
We haven't decided that yet, but we actually think that in order to bend the plastic, we would have to cut, like the cut would have to go a little bit higher or in between. So the screen might actually be like 2 to 3 inches higher than it is in the upper left photo.
I guess what I'm picturing is that just from the rigidity of that hinged cover, that if it was more or less centered between the top and the bottom edge of that angled portion of the cover, right, that it would be, you essentially aren't going to be weakening the cover, whereas where it is right now, that bottom outside corner of the cover is kind of fragile.
Okay, that's a great suggestion.
And it can be moved over a couple inches. Another thing to note is that our cover is not, our hood is not completely finalized. I'm thinking I'm going to add in a bigger angle bracket in the corner or some sort of gusset plate to kind of reinforce that, because right now the weight of the actual opening and closing hood is on a bar that's creating a moment with the back frame. Previously we had a vertical bar there, but due to our new linear rail design, we're thinking that that's going to need to be taken out to make room. So hood changes will still be coming. So just to note that for the structural integrity of the hood. And to put the electrical box actually attached to the hood, like the upper part of the hood, would definitely put a lot more weight and strain on the hood there. So just to note.
I guess I don't know that I was picturing attaching it to the hood, but that it would be attached to the frame, just that the hood would close over it.
Okay. And it's still, well, that's what we were originally planning, but you guys were mentioning I'm moving it up, but I suppose it could still be attached to the frame being moved up.
We are actually talking a lot about designing a custom 3D printed piece that would hold the electrical box into place, and if that box needs to come out a bit from the frame, that it would sort of provide a nice aesthetic around it, but that it would allow us the flexibility to position it where we need to position it. Do you have any thoughts about that?
I'm not sure if I followed that. Maybe try that again.
Yeah. We're considering making a custom 3D printed piece to hold the electrical box / touchscreen into place on top of that frame right there. So it's kind of like
It's a fixture.
Yes.
Yeah. So we're looking into that right now, but we'll probably have some more renderings to show how physically that would look. Patrick, do you want me to transition over to the Rails?
Yeah, certainly. So the other big thing to talk about is something we mentioned before, is that we would like to get rid of the V-grooved rails in the wheels and change to a precision linear rail system for the movement along the axes. The benefits of this are the linear rails are much more precise. They'll be for sure straight versus extrusion we get now. We have to quality test and examine the twist or the difference between that and being perfectly straight. They're not all perfectly straight, so we have to throw out some.
Yeah, record that 70 to 80% of the high precision railing that or extrusion that we receive from Michigan Extrusion. So that's like, it's a huge amount of culling and waste and opportunity for error in the kit that we send out.
So that's why we want to switch to the linear rail system, and also because since it is more precise, it's not going to be we're going to have easier travel theoretically. So we started mocking that up. It's in the early stages, and we're working on another project with the same linear rail systems also. So there are multiple groups within Re3D working on this. So this design is very important for us. And as you can see on the left picture would be the linear rails for the bed plate assembly, and those would attach, and there would be those instead of the V-grooved wheels in the thing. There'd still be a threaded rod that actually actuates motion up and down. So that's that there. We'd also have linear rails for the y-axis movement pictured in the top right, and there would be a little 3D printed or aluminum piece, most likely aluminum machined, that would hold the bridge rail in place, and that would allow the bridge rail to travel in the y direction. And then there would finally be a linear rail going across the top of the bridge rail, and on that would attach the actual gondola, the extruder cold end, hot end, and all that. So those are some of the ideas we're having. Some of the problems that we're running into is the interference between the block on the linear rail and the side paneling. A couple of possible solutions to that is we would turn the top of extrusion for the frame. That's currently 20 by 40, so we only have 20 millimeters to work with on the top there. We might make that a 40 by 40, double the space so that the slide and the block assembly would fit up on there and still within the paneling. Another idea is that we'd put the linear rails on the inside and that of the top bars, and that the bridge rail will go between those. So it would be slightly lower, or we could design a special connector piece to go up above. Deliberation, that's kind of our main focus at the moment on the CADing side, is how those would work and making sure that would all fit within our enclosure that we are working on. Any questions about linear rails or any of that?
That sounds good to me.
Yeah, I'm good.
Cool. So hopefully everything should run way more smoothly with linear rails once we get everything worked out. So just be ready for more linear rail updates.
Do you guys have any thoughts about linear rails versus like just the typical wheels that you have on your current Gigabot with extrusion?
Oh, a number of my wheels I just had to replace because they're not actually round.
Mm-hmm.
So I prefer linears.
Yeah, we didn't originally put this in the Kickstarter project, but we felt that because this is a community platform, that it would be great to have more people out there using the system, because we'd like to do all of our future hardware as it scales up with linear rails for the precision and accuracy and the longevity of use.
Yeah, I agree. Quite a few of my printers have linear slides on them, so.
Awesome.
We were hoping that you guys would be surprised and enthusiastic about the change.
Oh, I was in the makerspace there in Houston last week, so I saw.
Great.
It's a great space.
Yeah.
Alrighty.
Okay, so we are uploading all of this current work to the Revolve Air platform. Right now, the website we're muscling through because it's still a new company just like us.
They did an update last Tuesday?
They did an update to their website interface, and they've been getting a lot of attention for their open source design projects online, but ours is the most complicated project that's on their site. So we're actually one of their use cases that they're learning from about how the platform should react to such an expanded view of our project. And as you can see, the right picture, it's very difficult to actually see what's going on. And I've had about a couple calls a week with these guys to explain to them how we really want to use their platform and how we hope that you guys can pull all of the files very easily off of it and interact on it. And we're told that it's going to be more of a forum platform where you can engage with each other and engage with Re3D about the work that's up. But also we asked and requested for the nodes to be able to be collapsible so that you can see only the parts that you want to see. But our strategy going into this is really based off of how SolidWorks files work, which is that there are parts that you produce that you put into an assembly that you can put into even more complex assembly. And so that's how we're structuring it. And we're also attaching an image file to each of the nodes, a drawing file to each of the nodes, and then we just put up a link on Google Community to ask everyone's preferred assembly file type. So we will add SolidWorks files, but probably it sounds like step files are the most versatile file language that's out there. If you guys have any other suggestions about Revolve Bear, please let me know. And if you have any suggestions about how you want those files organized, we can talk about that right now too.
Yeah, just for some context, so as Katie mentioned, this is a startup, and their website was recently crashed by Reddit a couple times in the last couple weeks. So they're super responsive. They've met with both Katie and I about separate projects to make sure that they're in line with Re3D. We have a really close connection with them. So if you don't like this, please let us know, and we'll pass it along with them. And if you're willing to connect with them and give your feedback, they're super willing to hear it. Ultimately, they see themselves as like the GitHub of open source, like visual documentation and layout. And from my perspective, I don't see another company trying to pursue this. So if we can give them some insight into how they can do this better, this is a huge opportunity, because right now they seem to be kind of leading the charge in how we organize this type of information.
Has anybody here been to the Revolve Air site lately? Any of the backers?
No, but I'll take a look.
It's a little, the interface is just performed a recent update, so I'm just going to warn you, it's a little hard to view, but I did get in contact with them today, so I hope it was easy to look at soon.
My only comment was just that if it were not too difficult, that it would be nice to have the drawings. I'd have to perhaps take another fast look at that, but it seemed to me that I had to export the PDFs. They were like it wasn't something I could view. I couldn't view the drawings without the SolidWorks, the free SolidWorks viewer, right?
Really? Okay.
Yeah. Our idea right now is that the drawings would be in PDF form, so you don't have to use the SolidWorks viewer.
Yeah,
as if it was a piece of paper. That's what you want, correct?
That would be my suggestion. It would make it easier for most people to look at them. Like, it's neat to have the assembly that was up there and be able to, like I said, being able to open that in the SolidWorks viewer and so on. But as far as the actual drawings themselves, yeah, it would definitely be
so the
more
idea
user-friendly
is
to have them as PDFs.
Yeah, for sure. The idea is to have it the ability to use the open source documentation on whatever level you're going to do. So if you're just going to look at the drawings and look at the parts, then you can look at the JPEG images of the parts and subassemblies, or you can look at the PDFs of the drawings. And then we also want to provide open source documentation for one step further. If you want to physically go in and look at the actual dimension, well, you have the dimensions to draw, but if you want to go in and modify a part, we should have step files and perhaps other file formats for each part used, and then we will have one major assembly for the whole entire project, and that will have the sub-assemblies too. So if you get that, you can break it down if you're going to do work further. So we have those two layers. We have the surface layer for easy viewing without any CAD software, and then if you want to go deeper, you can open up the CAD files and do that.
Right.
All right.
Ron, thanks so much. This is really helpful, and Mike as well. Like, once you get into the platform, if you have any comments, they're pretty transparent with us, so this is a really great opportunity to help inform them on where they go with this. But it's super awesome because, again, like, we don't see anyone else doing this, and if they can try and make it better and they have some funding to do it, let's try and guide them in the right direction.
Great. So our next steps right now is we're focusing on testing the newest layout for the OpenGV PCB board. And this PCB board is based off of a CNC layout for heat management. There are about 400 connections on this board, and we're testing out various new features. The new features are a USB hub, motor fault detection, and the list. 1 second, sorry guys. Well, I don't have the list up right now, but we are hiring somebody to test these features out for us, and to also look at the electronics box and how it should be laid out based on heat management of all the components and how the heated chamber will affect the electronics enclosure. You guys have any thoughts about that? Right now we're looking at an enclosure that's about 8 by 6 by 4. That's the smallest box that's available, and we're looking at NEMA boxes because they're standardized safety ratings for different configurations, and you can actually get custom holes cut for GUI interfaces, control buttons, and the wire cable outlets. And we're probably looking at steel or something that will insulate the heat, basically keep the heat from coming inside of the box rather than conducting the heat, which would be more of what aluminum would do. Any questions about that, or anything you guys want us to look into?
So you're thinking that the heat from the heated chamber and from the printing is going to be more than the heat of the electronics?
Yeah, so it's interesting. The heated bed actually gives off quite a bit of heat, and I can attest to this. I have a one-bedroom apartment, and I've been running my Gigabot 24/7 over the last 3 to 4 weeks to try to manage like our current marketing and contract print queue. And you know, at 100-degree heat, I can tell you that I'm sweating in the middle of the night if I don't have my AC on. So it is definitely a concern, and thankfully, our chief hacker, Matthew, has had a lot of experience with this as he's developed Gigabot. And with that in mind, he suggested, so two things came of a conversation recently with Katie. He suggested that, one, we consider steel instead of aluminum because it has a lower conductivity and transfer of heat. And then secondly, he said that, you know, that may be why we want to consider having the electronics enclosure slightly removed or, you know, protruding from the surface as opposed to having it embedded like we originally intended, because he was concerned that it would just, like, you know, basically be a big conduit for the hot and cold air. Any thoughts you have about this are really welcome. That was kind of news to Katie and I because this isn't really our sphere, but it seems to be super valid and definitely something that we want to like engineer around as we go forward.
I agree that it is something you want to take into account. And overall, yeah, steel NEMA are more readily available and relatively inexpensive and so on.
Yeah.
Awesome. We'll keep you guys abreast of that and what decisions we make around that.
And then, you know, with the PCB, we currently do have a job posting listed to help us, like, ascertain and just to have a second set of eyes that what we did was great. And if there are any concerns that we should investigate, we want to hire someone that can help us mitigate them right away. So if you know someone locally in Austin or Houston that has that skill set, we're really open to chat with them. But it's been an ongoing discussion. At this point, the PCBs are done, and they're expected to arrive at some point this week.
We were hoping we'd be able to show them to you guys, but yep, they haven't come in yet.
Yeah, so now we're looking for like an external perspective to make sure that they're good to go. And if any changes need to be made, they'll be made. So hopefully by the next Hangout, we'll have a live demo, or
yeah, for sure,
we can show it to you physically.
For sure.
Cool.
Okay. So guys, thank you so much for attending today. Do you guys have any questions or anything else that you want to bring up?
Nope. Thank you.
Sean?
Just going back to that plastic hinge thing, it's not a removable hinge, but I didn't actually find one, and it might not be that practical in an actual clear acrylic type hinge, but as far as that's kind of what I was envisioning as far as a glue-on, like a hinge using water clear adhesive and so on. Aside from the fact that one's kind of reversed from what it sounds like we would need. The glue grooves on that are on the wrong side, I guess, is what I'm saying from what Patrick was describing.
Okay.
But that's kind of what I'm picturing, anyhow.
That's super cool. I never thought of like a glue-on hinge.
And on that page, there's a picture of one glued onto the corner of the acrylic box or whatever it is there.
Oh.
You can kind of see what I mean as far as it, you don't really see the adhesive and so on, right?
Can you add it to the community page, and we'll check it out later?
Sure.
Thank you.
Thank you. And then just to recap, So if we did go with the protruding electrical box design, you guys are okay with that? I know initially in our Kickstarter campaign and in the drawings that Katie provided, it was flush. But it seems like from an engineering standpoint, after doing a lot of research, it makes sense to have it a little bit offset and angled. Are you guys okay with that?
That sounds like an improvement.
Yeah,
Okay.
I'd rather not lose build volume.
Okay.
Oh, that makes a lot of sense. Yeah.
And I'd say we definitely consider having a way to pivot or slide it in and out for if you need to go through the doorway. Perhaps that would be our solution. You could slide it into the machine and then it would
When it's
move
not
through the doorway.
Yeah, so that it doesn't, again, another snag point, essentially.
Yeah, that.
But it would be moved.
That's one of the things.
That is moving, but you are building in the middle of
It
your.
can go in and out for doorway travel. So we'll look into that.
Yeah, but additionally, if it could slide into the machine, you're pretty much only building in the center of your platform at any given point, unless you're making something that's utilizing that whole platform, and obviously you'd want that functionality, but for the most part, if you could just slide it right into the machine, then
yeah. Do you have the option?
Because I get orders for like a batch of 100 parts, and I just take it.
Mike, that's great. That's a
incredible.
really good data point.
Are you? Hug?
I'd say the sliding would only be for when you need to go through doorways, mostly. So that would be extended most of the time.
And that's great to hear that you guys are less concerned about it fitting through a door and more concerned about just using the full capability.
Yeah, definitely in my case, for sure.
Okay. Okay, that's great. So the biggest, I'm just summarizing here, kind of ad hoc, because I transcribe for Katie and Patrick. It sounds like the biggest outcome of this conversation is we need to investigate the ability to glue on the piano hinges versus having a fastener. Is that correct?
Yes.
Okay. Yeah, we'll definitely do some research in the next month, and we should have some good pictures for you.
Well, guys, have a great night. Thank you so much for joining, and we'll see you in a month.
All right.
And
Thanks,
yeah,
everybody.
and componentizing that box, that the wiring is, disconnected. You can disconnect it. I definitely think that's a move in the right
That's really,
direction.
yeah.
I mean, you look at almost any consumer device. I mean, computers even. You look at cars. Everything is, have connection plugs, right? That so your wiring harness is not typically part of an electrical component like the control box.
Oh, that's a really good point.
Yeah, and we'll follow up with you, Mike, if you're still okay with that, to just gather your perspective and your knowledge about those connectors. Make sure that we're doing the right research. Okay, I think he dropped off, but okay, everyone. Well, have a great night. Patrick, thanks for presenting.
Yeah, thanks for coming, everybody.
Yeah. And for anyone that's still interested, we've been putting in a plug all week during our weekly meetings, but Patrick has this amazing art piece standing.
Oh, yeah.
Sitting,
would you mind sharing that, actually?
Fascinating.
That's my circuit board art up there. It's like 3 foot by, probably like 2.5 foot by 4 foot. I just took a bunch of circuit boards I found laying around that don't work and stuck them on there. Computer mice and whatnot. It's my backdrop for all of my web interfacing, as you can see here.
Yeah, it's cool because you're such an engineer, but you have this design side, and it's awesome to see that.
That's what I hope.
Thank you guys so much for showing up. We can't wait to see you next month and share our updates.
Have a good one. Thanks.
Bye.
All right, take care, everybody.